Copy down your target for today. Today you're going to be working on solving equations with variables on both sides. You're following the same steps that you've been following for the last couple of days. Isolate the variable, work backwards, and always check your answer. Pause the video, copy down the target, complete your warm-up, then press play. So for the warm-up, hopefully your work looks something like this. Don't forget your check step. You should have n equals 4. If you have questions, please pause and look at where you made a mistake or ask the teacher. All right, so again, to use inverse operations to collect the variable terms on one side of the equation now. Okay, you want to get your variables together, so on one side. To solve more complicated equations, remember that you may need to first simplify, like we saw yesterday, by using the distributive property or maybe even combining like terms. Try this first one. Pause, try it, then press play. See what you can do here. Okay, so I hope you've at least tried it. Maybe you just wrote down a line or two. You want to distribute first. We have this 1/2, so let's distribute it into the parentheses, and this is only one way to do it. You'd have 1/2 b plus 3 equals 2/3 b minus 1. It does not matter which side you take the variables to. What matters is that you just do the work right. I think it's easier to take the variables to the side where there's more, okay? So 2/3 is bigger than 1/2. I'm going to get rid of this negative 1/2 b over here and put it over on this side. That's going to leave me with 3 equals. I need a common denominator for this, so let's show the work for that. I would multiply this first one by 2 and the second one by 3. So I'm going to have 4/6b minus 3/6b minus 1. Now you can combine your like terms. You're going to have 3 is equal to a 1/6b minus 1. Then you're going to need to add the 1 to both sides. Sorry, my pen is not working right now. Give me a second. 1/6b, there we go, minus 1. So we add 1 to both sides, and you're going to have 4 is equal to 1/6b. How do you get b by itself? By now, we've seen so many fractions. Multiply it by 6 on both sides, and that's going to give you 24. 24 equals b, circle that. Last step, you should always check it. Mine's right over here. So there's your check step. Make sure you plug it in. Make sure you actually see if it works. Don't just say you're checking it. All right, so on the next example, Tana and Rustin are starting a nutrition program. Tana currently consumes 1,200 calories a day and will increase that number by 100 calories each day. Rustin currently consumes 3,230 calories per day and will decrease that number by 190. Try to set up an equation here. Solve it if you feel confident in it. Otherwise, if you want to work with me, work with me. So we're going to say that Tana's, we want to know if they continue this pattern, when will they both consume the same number of calories? So when will Tana's equal Rustin's? Let's pull some information out here. Tana has 1,200 calories a day and is going to increase by 100 each day. Rustin currently consumes the 3,000, I'm going to do a different color actually for this, 3,230, and he's going to decrease by 190 per day. So your equation should have Tana having 12,000 and adding to it 100 per day, while Rustin's going to have 3,230, and he's going to take away 190. Again, per day, so we need that D. When will they both consume the same? So when are they going to be equal? All right, solve by getting your variables and constants together. Remember that this is only one way to solve it. It doesn't matter which side you take the variables to. I'm going to take the variable to the positive side. So I'm going to have 100D equals 2,030 minus 190D And then we're going to add 190D to both sides. And then you're going to divide here to get D by itself. So D is equal to 7. One thing that I did not do here, somebody should have yelled at me from the beginning. Hopefully up here you defined what you were using. So D is going to be days. You should have that variable defined. I'm so sorry for not doing that initially. And then you should also label your answer anyways. All right, on the back, I want you to solve the two equations that you see on the back first. Solve them. Pause the video, try to solve them. They're gonna look a little weird, okay? And then we'll fill in the words and show our work together. So take a minute, pause the video, and try these two. You have special cases in equations, okay? You have contradictions and identities. An identity is an equation that is true for all values of the variable, which means it has infinitely many solutions. While a contradiction is an equation that is true for no solutions. It doesn't have anything. So it has no solutions or zero solutions. When you solve these two equations, you should have noticed that your variables end up canceling out. If I combine my like terms here, I would have 13x minus 3 equals, since these are on the separate side of the equation, I have to add them together first, 13x minus 4. Some of you may have noticed right here, wait a second, that looks weird. Keep going. You may do something different than I do, but I would get the variables together. So I'm going to get this 13x to go over there. No matter how you do it, you should end up with a line where the variables all cancel out. I end up with negative 3 equals negative 4. Maybe some of you ended up with, if you added 4 to both sides, with 1 equals 0. Regardless of what you end up with, look at this. Ask yourself, is this true? Write that down. Is negative 3 equal to negative 4? Ever? Is negative 3 ever equal to negative 4? No, that doesn't make sense. This would be a contradiction. There are no solutions to this equation. I want you to understand, if I ask you to solve, the no solutions is your answer, okay, this part. The contradiction is just the classification of the equation. It's what we call it. Let's try the next one. Here, when I combine my like terms, I have negative 12 minus 3f is equal to negative 3f, after I distribute, negative 3f minus 12. So if I add my 3f's to both sides, they end up canceling, and now I have negative 12 equals negative 12. You could keep going if you wanted. You could add 12 to both sides. In this case, then you would have 0 equals 0. Regardless, ask yourself, is this true? Does 0 equal 0? Or does negative 12 equal negative 12? Yeah. This is an identity, guys. That means there's infinitely many solutions. There's actually all solutions for this. This is all solutions. So again, the identity is just the classification. The all solutions is the answer. You're going to do some more of these. These I thought were pretty easy, so don't worry. I'm going to make them tougher on you. But know that these special cases do exist and that sometimes your variables can cancel in the equations. All right, guys, you're on to the quick check.